Welcome. Today, we are going to make multiplication feel calm, precise, and completely understandable. Every digit has a place, and every answer digit must land where its place value belongs. We begin with 24 times 6. The 24 is the multiplicand and the 6 is the multiplier. Both sit inside the place value table, so the meaning of each digit stays clear. We multiply from the right. 6 ones times 4 ones gives 24 ones. The 4 is the right digit, so it lands in the ones column. The 2 is really 2 tens, so it carries left into the tens column. Right digit lands, left digit carries. That is the rhythm. Now, complete 24 times 6. 6 ones times 4 ones gives 24 ones. 4 ones land in the ones column, and 2 tens carry to the tens column. Next, 6 ones times 2 tens gives 12 tens. The carried 2 tens joins that result. 12 tens plus 2 tens gives 14 tens. 4 tens land in the tens column, and 100 carries left. There are no more multiplicand digits, so the final carry becomes the hundreds digit. The answer is 144. Now, take 13 times 14. The 13 and the 14 are aligned by place value. We begin with the 4 ones in the multiplier. 4 ones times 3 ones gives 12 ones. The 2 lands in the ones column, and the 1 carries as 110. 4 ones times 110 gives 4 tens. Add the carried 110 and we have 5 tens. The first partial product is 52. Now move to the 110 in 14. This row starts in the tens column, so the 0 marks the shift. It is not decoration. It protects the ones column and reminds us that this row is working in tens. 110 times 3 ones gives 3 tens, so the 3 lands in the tens column. 110 times 110 gives 100, so the 1 lands in the hundreds column. The second partial product is 130. Now add the partial products. In the ones column, 2 plus 0 gives 2. In the tens column, 5 plus 3 gives 8. In the hundreds column, 1 remains, so 13 times 14 equals 182. Next comes 207 times 6. The 0 in the middle means 0 tens, but the tens column is still there. We do not skip a place just because the digit is 0. 6 ones times 7 ones gives 42 ones. The 2 lands in the ones column, and 4 tens carry left. Now 6 ones times 0 tens gives 0 tens. The carried 4 tens are waiting, so 0 tens plus 4 tens gives 4 tens. The 4 lands in the tens column. Now 6 ones times 2 hundreds gives 12 hundreds. The 2 lands in the hundreds column, and 1000 carries left. Since there are no more digits to multiply, that one becomes the thousands digit. So 207 times 6 equals 1242. The 0 held the place and allowed the carry to pass through cleanly. Now we move to 438 times 27. This example has 2 multiplier digits, so we build 2 partial products. Begin with the 7 ones. 7 times 8 gives 56. 6 ones land and 5 tens carry. 7 times 3 tens gives 21 tens. Add the carried 5 tens and the total is 26 tens. 6 tens land and 2 hundreds carry. 7 times 4 hundreds gives 28 hundreds. Add the carried 2 hundreds and the total is 30 hundreds. 0 hundreds land and 3 thousands carry. The first partial product is 3066. Now move to the 2 tens. This row begins in the tens column, so the 0 marks the shift in the ones column. 2 tens times 8 ones gives 16 tens. 6 tens land and 100 carries. 2 tens times 3 tens gives 6 hundreds. Add the carried 100 and the total is 7 hundreds. 7 hundreds land. 2 tens times 4 hundreds gives 8 thousands. The second partial product is 8,760. Now add the 2 partial products. 6 ones plus 0 ones gives 6. 6 tens plus 6 tens tens gives 12 tens, so 2 tens land and 100 carries. 0 hundreds plus 7 hundreds plus the carried 100 gives 8 hundreds. 3 thousands plus 8 thousands gives 11 thousands, so 1,000 lands and 1 10,000 carries. The final answer is 11,826. Every carry stays in its own column until the moment it is needed. Now, raise the standard with 1,234 times 256. The multiplier has 3 active place value parts, 6 ones, 5 tens, and 2 hundreds. We work through them from right to left. First, multiply by 6 ones. 6 times 4 gives 24, so 4 lands and 2 carries. 6 times 3 plus the carried 2 gives 20. 0 lands and 2 carries. 6 times 2 plus 2 gives 14. 4 lands and 1 carries. 6 times 1 plus 1 gives 7. The first partial product is 7,404. Now multiply by 5 tens. This row begins in the tens column, so 1 0 marks the shift. 5 times 4 gives 20, so 0 tens land and 2 hundreds carry. 5 times 3 plus 2 gives 17. 7 hundreds land and 1,000 carries. 5 times 2 plus 1 gives 11. 1,000 lands and 1 10,000 carries. 5 times 1 plus 1 gives 6. The second partial product is 61,700. Now multiply by 2 hundreds. This row begins in the hundreds column, so the first 2 places are held. 2 times 4 gives 8 hundreds. 2 times 3 gives 6 thousands. 2 times 2 gives 4 10,000s. 2 times 1 gives 200 thousands. The third partial product is 246,800. Adding the 3 partial products gives 315,904. This is a large calculation, but the method has not changed. Align the places, multiply from right to left, carry into the next column, then add the partial products. Decimals use the same place of value logic. The columns do not stop at ones. They continue to tenths, hundredths, thousandths, and beyond. Each step to the right is 1/10 of the place before it. 1/10 of 1/10 is 100th. 1/10 of 100th is 1,000th. The landing column is decided by both place values. This is why tenths times tenths gives hundredths. Tenths times hundredths gives thousandths. It is not a random shift, and it does not carry on forever. The product lands in the column named by the place values being multiplied. After that, carrying still moves left in groups of 10. Now, look at 4.6 times 3. 3 ones times 6 tenths gives 18 tenths. 8 tenths land, and 1 whole carries left across the decimal point. Then 3 ones times 4 ones gives 12 ones. Add the carried 1, and the total is 13 ones. The decimal point is fixed by place value, so the answer is 13.8. Now take 2.35 times 4, start at the hundredths. 4 times 5 hundredths gives 20 hundredths. 0 hundredths land, and 2 tenths carry left. That 0 matters because it shows the full place value of the result. Now 4 times 3 tenths gives 12 tenths. Add the carried 2 tenths, and the total is 14 tenths. 4 tenths land, and 1 whole carries left. Now 4 times 2 ones gives 8 ones. Add the carried 1, and the total is 9 ones. The decimal point locks into the answer, giving 9.40. That is the same value as 9.4, but the 0 first shows exactly where the hundredths landed. Now, consider 0.48 times 0.7. Be careful here. The multiplier is not 7 ones, it is 7 tenths. Both numbers are less than 1, so an answer such as 3.36 is too large. Before multiplying, decide the landing places. 7 tenths times 8 hundredths lands in thousandths, because 1/10 of 100th is 1,000th, so the first result belongs in the thousandths column. It should not land in ones, tenths, or hundredths, because those places would be too large for what we are multiplying. 7 tenths times 8 hundredths gives 56 thousandths. 6 thousandths land, and 5 hundredths carry left. Next, 7/10 times 4/10 gives 28 hundredths because tenths times tenths gives hundredths. Add the carried 5 hundredths and the total is 33 hundredths. 3 hundredths land and 3/10 carry left. Finally, 7/10 times 0 ones gives 0 tenths. Add the carried 3/10 and the total is 3/10. The decimal point stays fixed and the leading zero is shown clearly. The answer is 0.336. Multiplying by a decimal can make a number smaller. The table keeps the answer accurate because every digit lands in the column that matches its value. Now finish with the full method. First, align the digits by place value. The multiplicand and multiplier must both sit in their correct columns. Second, multiply from right to left. When you get a 2-digit result, the right digit lands in the current column, and the left digit carries into the next column to the left. Third, add the partial rows column by column. Carries during addition follow the same place value rule. The table is not decoration. It is place value keeping the calculation honest. When the columns are clear, the digits know where to go, and the answer is built with confidence. Multiplication is place value in motion.